All right, so we're looking at this annular volume, and we're going to look at this as a solid cylinder, subtracting out a smaller solid cylinder from the inside. So this volume should be, the surface area of this cylinder is pi r squared, and then we need to multiply that by a delta z in length. And then to subtract out a smaller cylinder of that same length, delta z. All right, so now we know this outer radius is actually r plus delta r. Delta z minus pi ri squared delta z. Okay, so now we need to actually work out this quadratic. So we'll have r squared plus, we're going to have 2r delta r, and then we'll have plus delta r squared, delta z, minus pi ri squared, delta z. And that ri was just r, so I guess we can call that ri here. And then we'll drop that I because that's just the inner radius that we had. We had r and r plus delta r. All right, now we can distribute this. So we have pi and delta z that needs to be distributed throughout this equation. Let's see, we got pi r squared delta z. We have plus 2 pi r delta z. All right, then we have plus pi delta r squared delta z. Minus pi r squared delta z. So we have plus pi r squared delta z minus a pi r squared delta z. This goes away. We have this term. This term is a little messy, so it's pi delta r squared delta z. We are going to assume this term is 0. We assume it's 0 because delta r is very small. Right? We pick delta r to be very small. So if delta r is 0.1 and we square it, we get 0.01. If it's 1e negative 3 and we square it, we'll have 1e negative 6. So what we need to do is, we are already working in a very, 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 very small volume. And so we assume that this delta, as we square it, becomes 0. And so what we're left with then out of this whole thing is this 2 pi r delta z. So that's what we're left with at the end of the day. All right, so we did that work to kind of get our control volume.